Section 7.2, the mean and standard deviation of the sample mean. So of the sample mean, this means that what we learned in the previous section, you know how we found the means, several means from one sample. Like we paired them, or we take 3 at a time and then find the mean for each group. And here what we're going to do is we're going to find the mean and standard deviation. So the mean, just recall, again, the mean of the sample is x bar for the sample, and for the population is this. For the population is this. So what are we going to do with this is that we are going to first start by defining what is the mean of the sample mean. What is the mean for the sample mean? So we usually write mu sub x bar to represent the mean for the sample mean. And what is it? So that sample has size n. It's equal to the mean of the population mean. It's equal to the population mean. And I'll prove to you this by numbers in a minute why this works. So always this is saying the mean for the sample mean is equal the mean of the population, or the population mean. Okay, and we will come back to the standard deviation in a minute. So let's look at the example from previous section. We have 5 players and the height of each one is given, as you can see. I found the mean that we found in this is the population mean we found in the previous section, which is 80 inches. And then also what we did in the previous section, we had the means listed in a table for us. The means for a sample of size 2 were these: 77, 77.5, 78.5, 81, all the way to 83.5. Those are the means for a sample of size 2. Now I'm gonna find the mean for the sample mean. So these are the sample means. I'm gonna find their mean by adding them and divide by their sum, or the number of those means, which is 10. If you do that, you're gonna get 80 inches. Notice the 80 matches the 80, and no matter how you do it for any sample size, if you pair them by 3 or 4 or 5, you know, for this specific data or any other data, you will always get the population mean is equal to the mean of the sample mean of the sample mean. So that's about the mean of the sample mean. Now for the standard deviation, we're going to spend more time on this. Here you go. So if we have a sample of size small n, the standard deviation of the mean equals the standard deviation of the variable, you know, under consideration, divided by the square root of the sample size. This is the mean, the standard deviation for the population, let's say. So how do you find that out? Well, we use the formula, the square root of the sum of xi minus mu squared over n, which we did before from previous sections or previous chapters, somewhere in one of the previous chapters. So we're going to take the same data that I had in the table up there, and I wrote the formula here. So I'm going to first find the population standard deviation. You can either use a table, or you can do it like this. So the data that was given to us, the heights were 76 minus the mean, population mean was 80 squared, plus, because that's what the sum means. The second one, 78 minus 80 squared, plus 79 minus 80 squared, plus 81 minus 80 squared, plus 86 minus 80 squared, over n, which is sample size, the population size, which is 5. And now if we do the calculation, 76 minus 80 negative 4, you square it, you get 16. You can do that on the calculator. 2 squared is 4, 1 squared 1, 1 squared 1, and the last one is 6 squared, 36 over 5. And that gives us the square root of 11.6, which is about 3.41 inches to 2 decimal places. That is the population standard deviation. Then the standard deviation for the sample mean, or the means of the sample, this one equals the one we found divided by the square root of n. So that would be 3.41 over the square root of 10. Okay, if you want to do it this way. Or let's see if we put this on the calculator, what is that gonna give us? Okay, let's put that in the calculator right now. Divided by the square root of 10. Okay, by 10. That gives us, no, I put a different number. Okay, by the square root of 10. That gives us about 1.07. But for the meantime, what we need to do, we need to try to approach it not in this way. I'm gonna really actually find it for the numbers they have using the same formula as the one I just showed you. So for the sample means, the means, if you remember the ones I wrote earlier, these ones, these are the means. So I'm gonna find the standard deviation for these 77, 77.5, and so on and so forth. So 77 minus 80 squared plus 77.5 minus 80 squared plus plus 83.5 minus 80 squared, all divided by 10. We have 10 of them. And then all we have to do is just add all the numbers up. 6.25 plus 12.25, all that divided by 10. If you calculate it, that would be about 2.09 inches, rounded to 2 decimal places. So what we are going to do here, I'll come back to the other formula. Now if we do it, if the sample size that I showed you in the previous section, let's say the sample size was 3, guess what this is going to be? I did the calculation on the side, I got 1.39. If the sample size is 4, this one, the standard deviation for the sample mean is 0.85. If n is 5, then this one would be 0. So what does that tell us? This tells us the standard deviation for the sample mean gets smaller as the sample size n gets larger. Do you see that? As the sample size gets larger. This is important to know, to keep in mind. This means the variation of all possible sample means, they decrease or decreases as the sample size increases. Okay, as the sample size increases. And we can see it from the formula that I gave earlier. This equals this, the standard deviation over n. So what this is saying, as n increases, this decreases. Because, you know, in general fractions, the larger the denominator, the smaller the fraction. The larger the denominator, the smaller the fraction. Now, is there a formula that connects this with that? Yes, there is. There is a formula, of course. So what we have is, could you have used this in the previous work? Yes, you could. But wait, I'm not gonna get the same exact sense. That's okay. It's an approximation, but the only thing here we need to see is really, even if you use this formula, as n increases, the standard deviation for the sample mean decreases. That's another important thing to keep in mind. So that was the main thing. Two things in here is how to find the mean and the standard deviation of the sample mean. These are the two things. Now there is a slightly different formula, but we don't need to know it for now. This talks about when we have only a finite population, not infinite, and then when we do work with or without replacement, but that's not needed for this chapter. All you need is this formula that you see here that I introduced, or you can just run the calculation as I did from scratch. So two formulas are needed, the ones I wrote earlier, this one here and this one here between the parentheses.